In this video, we are going to be looking at more examples on the Bernoullis differential equation. We did a video like that. You can check the YouTube channel or send me a shout out. Okay, now please, before you continue, there's a subscribe button down there. You can click to subscribe so that you can get more of our videos. Okay, so we have our first question here: x dy dx plus y equal to y squared ln x. Okay, not looking exactly like the Bernoullis equation, but we can rearrange it to look like it. Okay, so the first is to divide through by x, of course. So if we do that, we are going to be having dy dx now plus y over x equal to y squared ln x all over x. Now, but like we said, it is not looking like a Bernoullis equation. So we can divide through by y squared, and if we do that, this is going to give us y raised to power minus 2 dy dx, okay, plus y raised to power minus 1 over x, then equal to ln x all over x, which is looking exactly like the Bernoullis equation, which is supposed to be y raised to power minus n dy dx, okay, plus y raised to power minus n plus 1 p, then equal to q. Okay, so if you compare, you can see that your p is 1 over x and your q is ln x over x. Now, why do we say that this is the same thing as this? Because if I differentiate y to power minus 1, I'm going to get y to power minus 2. Now, from there, we can see that we can start by saying let v be y raised to power minus 1. That's to solve, and that means our dv would be equal to minus y raised to power minus 2 if we differentiate dy, differentiating implicitly. Now, if we can divide both sides by dx, okay, and we have this. So that means since there is a minus here, we can say that minus y raised to power minus 2 dy dx now is equal to minus dv dx. Okay, so minus dv dx. Now, if we substitute the values, this is exactly what we are going to get. If we substitute the values, we are going to get your y raised to power minus 2 dy dx becomes minus dv dx, then plus 1 over x times your y raised to power minus 1 is v, then equal to, here we already have ln x over x. Now, at this point, we can take care of this minus, multiply through by minus 1, and we are going to get dv dx minus v over x equal to minus ln x all over x, which is exactly what we have here. And that is a first order linear equation. So in order to continue to solve a first order linear equation, we start by getting the integrating factor, which is rho, which is exponential, minus integrating factor is exponential integral of p dx. Okay, so our p in this case is 1 over x, so integral of exponential 1 over x dx, not just 1 over x but minus 1 over x, and that will give us exponential minus ln x, and exponential minus ln x is exponential ln x raised to power minus 1 according to the law of indices. Ln cancels exponential, so what we are left with is 1 over x. So that's the reason for this. So our integrating factor for the first order linear equation is 1 over x. Now, that leads us to the next point, which is the solution to first order linear equation, which is rho v equal to integral of rho q dx. Okay, your rho, already integrating factor is 1 over x, so times v equal to integral of minus 1 over x ln x. Remember, your integrating factor is 1 over x, then multiplied by your q is minus ln x over x. Okay, that's the reason why we have minus 1 over x ln x over x dx. Okay, so if we multiply that, the denominators here, x times x gives us x squared here, then your minus can come outside the integral sign. Now, to continue further, we have v over x equal to minus ln x over x squared dx plus c. And your ln x over x squared is the same thing as x to power minus 2 if we bring it up, ln x plus c. okay, which we cannot integrate by any other method except by using integration by parts, which is what we have here, uv minus integral of v du, where our u here would be ln x, okay, the differentiable function, then y our dv is x to power minus 2. Okay, from u we can find du, differential in x, we are going to get 1 over x. Then from our dv we can find v. If you integrate dv, you are going to get x raised to power minus 1 over minus 1. That's when you add plus 1, you know, and that is going to give us minus 1 over x, and that is exactly what we have. So your uv now, u times v, so ln x times minus 1 over x gives us minus 1 over x ln x. Then we have our v du, this is v and this is du, which means minus 1 over x times 1 over x. That's exactly what we have here. Now if we continue from there, you see that 1 over x times 1 over x gives us minus 1 over x squared plus c. Now we continue from there. That's exactly what we have. At this point here, your minus here gives us plus. Okay, and your 1 over x squared means x to power minus 2, which we can easily integrate. X to power minus 2, to integrate that means x to power minus 2 plus 1 over minus 2 plus 1. That's actually why we have x to power minus 1 over minus 1, which is minus 1 over x, okay? And that's exactly what we have here. And if we substitute, you can see that your minus, your negative value here can open up the bracket, and we have here to become positive. And since, remember, our v is y to power minus 1, which also means 1 over y. If I substitute the value for 1 over y for v, we are going to get 1 over xy, and that's the reason why we have this as our final answer. You can choose to make y subject of formula, and you know, to leave your answer that way. Now that leads us to another question here. Okay, we have x dy minus y plus xy cube into 1 plus ln x, okay, dx equal to 0. Now we want to rearrange this to look like a Bernoullis equation, so I can start by dividing through by x. And if we do that, your x dy now becomes dy dx, and your y now divided by x, you have y over x. Divide the whole of this is multiplying, so divide the whole of this by x, you have your y cube into 1 plus ln x, which is what we are supposed to have. Now when we open the bracket, the minus sign now affects, or to have minus y over x minus y cube into 1 plus ln x. Okay, at that point we can take this to the other side of the equation. That's why we have this to be equal to y cube. The minus sign becomes positive, y cube ln 1 plus ln x. Now that is what we have. Now at this point we can choose to divide through by y3, you know, to look like a Bernoullis equation. So when we divide this by y cube, we get this. Divide this by y cube, y over y cube actually is y to power minus 2 using the laws of indices. Okay, and that is why we have this. Then divide this by y cube, it eliminates y cube, we are just left with this, which is a first order linear equation. Which is a Bernoullis equation, which looks like y raised to power minus n dy dx, okay, then minus y raised to power minus n plus 1 p equal to q. So you can see that your q is this, okay, and your p is minus 1 over x, then 1 attached to. So to solve this, we can start by saying let v be equal to y raised to power minus 2. So that means your dv now becomes minus 2y raised to power minus 3. You see that? We can divide both sides by dx. So that means your dy here. That means your y to power minus 3 dy dx is equal to minus 1 over 2 dv dx, okay? So in place of y to power minus 3 dy dx, we have minus 1 over 2 dv dx. Now if we continue from there, you can see now to substitute, this guy now becomes minus 1 over 2 dv dx, okay? Then why this now becomes minus v, okay? Your y to the power minus 2 is v, minus v over x now equal to 1 plus ln x. So at this point in time, to allow this to be dv dx, to make it look like a first order linear equation, we can multiply through by minus 2, and if we do that, we are going to get dv dx, then here becomes plus 2v over x equal to 2 into 1 plus ln x. You see that? Okay, so that's exactly what we did. Okay, this should be minus 2. You are multiplying through by a negative 2. So we got this particular value, which is a first order linear equation, which we get by first of all finding the integrating factor, which is exponential px. Remember that p is a function of x that is attached to v. So, and that function of x is 2 over x. So, exponential integral of 2 over x gives us exponential 2 ln x. Integral of 2 over x is 2 ln x, and exponential 2 ln x is the same thing as saying exponential ln x raised to the power 2. Remember the law of logarithm, so this cancels out and we are left with x squared. Okay, so going back to the solution of a first order linear equation, our integrating factor rho is x squared, then you have your v. Then your integrating factor x squared multiplied by your q, which is minus 2 into 1 plus ln x. Now if we open these brackets, we are going to get minus 2x squared, okay? Then plus x squared ln x. Okay, or we can say, let's clean this up. Let's put that again. You have your integrating factor, which is x squared, then multiplied by this, which is minus 2 1 plus ln x. Okay, so your x squared times minus 2 gives us minus 2x squared into 1 plus ln x, which is exactly what we got here. And we need to integrate this, and the only way we can integrate that is using integration by parts, where we can start by saying our u here would be 1 plus ln x, because we can integrate ln x, differentiate ln x but not integrate it. Then our dv is minus 2x squared. Okay, so from u we can find du. Differentiate ln x is 1 over x, differentiate 1 is 0. Then from dv we can find v, which is to integrate minus 2s squared, and that will give us minus 2s cubed all over 3. Okay, so if we are substituting value, uv now would be minus 2s cubed all over 3 into 1 plus ln x. Okay, then minus integral of v du, your v du. Your v du means you multiply 1 over x by minus 2x cubed all over 3, and that will give us minus 2x squared all over 3. Okay, which is exactly what we have here. Okay, and you can see here that this is giving us this is leading to this. Okay, minus 2s squared over 3, because your x here cancels this to give us 2, and this remains the same here. There's supposed to be a negative sign here, okay? So, and that leads us to what we have here, because when we say minus gives us plus, you are going to have plus integral, that's integral of 2s cubed over 3. Sorry for that mistake there. And when we integrate 2s cubed over 3, we are going to get 2 over 3 times integrate x squared is going to give us x3 over 3. So that will give us 2x cubed all over 9. So we correct that. That now leads us to the final answer here. When we substitute your v to be y raised to the power minus 2, then here is minus 2x cubed over 3, 1 plus ln x. Then here, like we just corrected now, is 2s cubed all over 9. So that means we can write the answer as s squared y minus 2 equal to minus 2s cubed over 3 into 1 plus ln x. then plus 2s cubed all over 9, then plus c. Thank you very much for watching. Don't forget to subscribe, press the subscribe button in case you failed to do it the first time. Thank you very much. Have a nice day.